Hello, my name is Tete Jacobson Richard and welcome to my YouTube channel. Today our discussion on ordinary differential equations will be on application of first order ordinary differential equations. We said that first order ordinary differential equations are mostly applied in growth and decay problem as well as dilution and mixture problems. I have a video covering the growth and decay problem. Please check it out on YouTube. Today our discussion will be on dilution and mixture problem. This will be a very interesting engagement. Please take a seat. So let's say that LB in this is stand for pound. The LB, that's the standard unit for pound. So please consider that. Let's consider a jar or a tank having an initial volume of solution, maybe V naught, containing a salt of A pounds. So we have a tank with an initial volume of a solution and the salt in that solution is of A pounds. Then another salt of B pound is added at a rate of E gallons per second. That means at every second we add E gallons. And we outlet it, that we let it come out at a rate of maybe F gallons per second. So if Q is the quantity of salt at any point in time, T, let's see what happens. So now let's have a visual representation of what I wrote there. So let's say this is the jar containing an initial volume of solution, V naught, okay? And the salt in this solution is A pounds. Then we add another salt solution or another solution, being a salt solution or fresh water. So when it is fresh water, the pounds of salt in it will be 0. Please take note of that. So we add another solution of salt at B pounds. Another solution of salt of B pounds at a rate of E gallons per second. E gallons per second. Then we outlet it just as it is represented in the writing there. We outlet it at a rate of F gallons per second. Now, let's consider that, or let's take it that our R in, Ri, is the quantity of salt solution that enters the jar at any point in time. And our R O or R out is the quantity of salt that comes out of the jar at any point in time. Then the quantity of salt that we have in the jar at any point in time, that's the Q over dt, will be equal to the quantity that enters the jar minus the quantity that leaves the jar. I hope you get that. So we can say dq over dt is equal to R in minus R out. I hope you get that. Now let's come back to this. So if let's say we have the salt, another salt of B pounds is added at a rate of E gallons per second, then the total quantity of salt that we add will be the rate times the quantity of salt that we add. So that's the quantity of salt solution that enters the jar. Then we can say this is our R in. I hope you get that. The rate at which that it enters times the quantity. So we can say our R in is B times E. Now, if we have an initial volume of water, then we can say that the volume of an initial volume of salt solution, then we can say that the volume of salt solution that we have is V naught. Now we let another quantity enters. That quantity is E gallons per second. Then we can add that quantity at any time t. So at any time t, the number of gallons that enters will be added to the initial volume that we have. Now we have another one being outlet at F gallons per second. Then we can say that one to come out F minus F at any time t. So this will be the quantity of salt that will remain in the jar at any time t. The initial volume plus the one that we added minus the one that comes out. So take it that you have 5 cedis in your pocket, you work and get 10 cedi. You add the 10 cedi to the 5 cedi. Then you meet a friend and you give 2 cedis to the friend. So you have 5 cedi, you work and get 10 cedi, you add it, then you give 2 cedi to a friend, you subtract that one. The amount that you have, the quantity of volume that you have will be this, an equation like this. Now, we have a quantity of salt, and this is the volume of salt solution. Then we can say that the quantity of salt that we have in the jar at per gallon, okay, will be the quantity of salt per gallon, will be the total quantity of salt divided by the volume of salt. That's, I hope you get that. Divided by the volume of salt. That will be the amount, the quantity of salt that we have in 1 gallon. In 1 gallon. Okay. So now, if we outlet this at a rate of F gallons per second, then the total quantity that we outlet will be this times F. So 1 gallon contain this quantity of salt. Then the one that we outlet at any point, that's F gallons per second. Then F times that gallons that we outlet. So we can say that this is the quantity of salt that comes out of the jar. So we say R out. Then we can substitute our R in and our R out into this equation. I hope you get that. So we'll substitute that. That will be the next thing. Then we take it from there. So from our explanation, we said the quantity of salt that we have in the jar at any point in time will be the quantity of salt that enters the jar minus the one that comes out. And we say in the explanation that the one that enters will be BE and the one that comes out will be RO, which will be given as this. I explained that already. So let's just substitute. So the quantity of salt at any point in time, we call BE, RE. That's the one that enters is BE. Then minus the ones that comes out. So let me write the F first to multiply that. Q over V naught plus E at any point in time minus F at any point in time. I hope you get that. So let's make our BE the subject. So we can say dQ over dt plus F times Q over V naught plus E at any point in time minus F at any point in time is equal to BE. I hope you get that. So if the problem is given to us, all what we need is this. Then we locate our V naught, locate our E, locate our F, locate our B, then we substitute, then we start solving. When we substitute, we'll be able to know which first order ordinary differential equation will be applied in solving it. We'll take a sample question so that we'll apply this for you to get a concept. So look at our first example. They say a 300-gallon tank initially contained 100 gallons of brine containing 50 pounds of salt. A brine containing 2 pounds of salt per gallon enters the tank at a rate of 6 gallons per second. And the well-stirred brine in the tank flows out at a rate of 3 gallons per second. Find an expression for the quantity of salt in the tank at any time t. Then B, the time at which the tank will be full with salt solution. So we'll try to find solution to this. Now listen, we said that the quantity of salt in the gallon at any point in time t plus the quantity that leaves, that's V naught plus E of t minus F of t is equal to BE. So locate the necessary things. So the initial volume, So let's locate the necessary thing. So the V naught is the initial volume of salt. F is the rate at which the solution is outlet. The well-stirred solution is outlet. E is the rate at which it was poured inside. And B is the quantity of salt solution that was added. So let's count. So they say a 300 gallon of tank initially containing 100 gallons of brine. So we can say this is our V naught initially. So this is our initial volume. So we say V naught is equal to 100 gallons. So we locate the initial quantity of salt, the initial quantity of solution that will be in the tank is 100 gallons of brine containing 50 pounds of salt. So we can say that's our A. Our A is equal to 50 pounds of salt. So we locate the A. Then a brine containing 2 pounds of salt per gallon enters the tank. So that will be these 2 pounds will be our B. We say B is equal to 2 pounds. At what rate? At a rate of 6 gallons per second. So that's our E, the rate at which it enters. So E is equal to 6 gallons per second. Then the well-stirred brine in the tank flows out at a rate of 3 gallons per second. So that's our F, the rate at which it comes out. So we say our F is 3 gallons per second. Then we substitute. So we say our Q naught, our quantity of salt at any point in time t plus what's our F? Our F is 3. So 3 bracket the quantity of salt that we have a V naught 100 plus the rate at which it enters, that's 6 minus the rate at which it's leaving, which is a 3 minus 3, and it's equal to B, the rate, the quantity that enters, 2, then times the rate at which it enters, 6. I hope you get that. We just substitute. Now let's solve this. So our dq over dt plus 3 bracket q all over. So 100 plus 6 minus 3, that will be 103. So 100 plus 6, 106 minus 3 will be 103. Is equal to 2 times 6 is what? Is 12. Now we can rewrite this as this dq over dt plus 3 over 103 q is equal to 12. Look at that. Our big formula is reduced to a very simple form. Now look at this. Which first order ordinary differential equation is this? Look at this, is in the form q prime plus p of t q equal to r of t. So it is linear first order ordinary differential equation. So what do? We find the integrating factor. The integrating factor is e exponent p of t dt. And what's our p of t? Our p of t here is just 3 over 103. So we just substitute and find our integrating factor. Then we take it. So let's find our integrating factor. We say our integrating factor u of t will be equal to e, the integral of p of t dt. So this will be e, what's our p of t? Remember is this. So that will be the integral of 3 over 103 dt. This is constant. So when we solve this, we'll get the integral of this is just the attachment. So we'll get e exponent 3 over 103 t. I hope you get that. So remember when we're solving linear first order ordinary differential equation, after we find the integrating factor, please check out my videos on how to solve linear first order ordinary differential equations. After we find the integrating factor, we multiply the integrating factor through the equation. So this is our integrating factor. We multiply through the equation. We have e exponent 3 over 103t dq over dt plus e exponent 3. So let me bring the 3 over 103 first. 103 e exponent 3 over 103 t q equal to 12 e exponent 3 over 103 t. I hope you get that. So remember, we said immediately we multiply the integrating factor through our linear first order ordinary differential equation. The left hand side of the equation will be the product differentiation of the integrating factor and the dependent variable, if you remember that. So our dependent variable is q and the integrating factor is d. So we say q e exponent 3 over 103t all prime. So look at it, this product differentiation. When I keep my integrating factor and differentiate q, I'll get dq over dt plus product rule. Now I'll keep my dependent variable and differentiate the integrating factor. See, the differential of the is just we'll differentiate the exponent. So when we differentiate 3 over 103 t, we'll get 3 over 103 and use it to multiply the function. We'll get it back. So it will be equal to 12 e exponent 3 over 103 t. Now what do? We integrate both sides. So this will be the integral of q e exponent 3 over 103 t all prime equal to 12. It is constant. That's why I bring it up. E exponent 3 over 103 t dt. So let's integrate this. Remember we said anytime the integral means the differential, the answer is the function. So this will be nothing but q e exponent 3 over 103 t and to be equal to 12. Remember how to integrate this. We'll differentiate this and use it to divide. So this will be e exponent 3 over 103 t all over 3 over 103. So when we differentiate this, it will be 3 over 103. Then plus our constant c. Now we can solve the c. 12 over 3 over 103 is the same as 12 times 103 over 3. 3 will go into 12 4 times. 4 times 103 will be 412. So we can say that this will be 412, multiplying that. So we say q e exponent 3 over 103 t will be equal to 412 e exponent 3 over 103 t plus c. What do? We will make q the subject by dividing both sides by. We divide through by this. Here e exponent 3 over 103 t, e exponent 3 over 103 t. So you can see this will divide that. Q will be equal to, see this will also divide that. What is left? We are only left with 412. Then plus, I can rewrite this as c e exponent negative 3 over 103 t. I hope you get that. So when the tank contains an initial volume of sort of 100 gallons, there is a 50 pounds of salt. That 50 is what is here. So at the time that the solution contains 50 pounds of salt, the initial pounds of salt of 50, the time there will be 0, if you get it, initial. So we can say that at Q of 0 is equal to 50. So we substitute when Q is 50 and T, so Q of T is this. So when Q is 50 and T is 0, we substitute to find our constant. So we can say that 50 will be equal to 412 plus plus C E exponent negative 3 over 103 times 0. You can say 50 is equal to 412 plus C, this will be 0. E exponent 0 is 1. So 50 will just be equal to 412 plus C. So our C will just be 50 minus 412, which will be equal to negative 362. So in place of C, we'll substitute negative 362. And that will be the expression for the quantity of salt in the tank at any time t. I hope you get that. So we find Q of t to be this, and we calculated for C. So we just substitute to get the first aspect of our equation A. So Q of t will be equal to 412. In place of C, we'll put negative 362. E exponent negative 3 over 103t. So this is the A aspect of the equation. The next is to find the B. So given any quantity of salt, we can find the time. And given the time, we can find the quantity of salt in the solution. So the second part of the equation is the time at which the tank will be full with salt solution. Remember, the tank is of volume 300 gallons. So at the time that the tank will be full with salt of 300 gallons, at what time will the tank be full with a salt solution of 300 gallons? That's why they're asking. So when Q is equal to 300, what is T? So now let's come here. So we know our Q to be equal to 300. Then we find our T. We substitute the Q into this equation. So we can say our 300 is equal to 412 minus 362 E exponent negative 3 over 103 T. What do? We bring this one. So we have 300 minus 412 will be equal to negative 362 E exponent negative 3 over 103 T. 300 minus 412 will be negative 112, and to be equal to negative 362 E exponent negative 3 over 103 T. We divide both sides by 362. So we can say our 112, since it's negative, when I divide to the positive, 112, negative 112 divided by negative 362 will be equal to E exponent negative 3 over 103 T. When we divide this, 112 divided by 360, since they are negative, the negative will cross out. The answer will be in positive. Will be equal to 0.3092, and to be equal to E exponent negative 3 over 103 T. What do? We find ln on both sides. So we say ln 0.3092 will be equal to ln E exponent negative 3 over 103 T. So ln 0.3092 will be negative 1.1731. And we say that anytime the ln the exponential function, the answer is nothing but the function there. So this will be negative 3 over 103 T. How do we find T? We divide both sides by that. So we say our T will be equal to negative 1.1731 all over 3 over 103. So our T, when you do that, you get 40.2. So we say that the tank will be full with salt solution when it is 40. So our approximate is when it is 40 seconds. I hope you get that. This is a very interesting one. Please play over the video, and I know that you will get a concept. So let's solve another question. They say a tank initially holds 100 gallons of brine solution containing 20 pounds of salt solution at time equal to 0. Fresh water is poured into the tank at a rate of 5 gallons per minute, whilst the well-stirred mixture leaves the tank at the same rate. Find an expression for the amount of salt in the tank at time t. Then the amount of salt in the tank at t equal to 1 minute. So now let's locate the necessary unit. So a tank initially holds 100 gallons. So that's our initial volume. V naught is equal to 100 of brine solution containing 20 pounds. So that's our A, initial quantity of salt there. So that will be 20 pounds. It's of salt solution at time T equals 0. Fresh water. So fresh water is poured into the tank at a rate. So now when we pour fresh water into the tank, that means it does not contain any quantity of salt. So we can say that our B there is 0 pounds of salt. Then it's entering the tank at a rate of 5 gallons per minute. So that's our E, the rate at which it entered. So that's 5 gallons per minute. Now they say it leaves the tank at the same rate. Then the F is the same as the E. So we say our F is also equal to 5 gallons per minute. Then we just substitute into our expression, then we solve. We will determine which first order ordinary differential equation we use to solve it. So we said that the quantity of salt in the gallon at any point in time, that's the Q over dt, plus F, our Q over V naught, plus E at any point in time, minus F at any point in time, okay, will be equal to BE, if you remember very well. So we substitute. So our dq over dt, what's our 5? Our F is 5, so 5. Q over V naught, 100. E, 5. F, also 5, so minus 5. Is equal to, our B, remember, is 0. So 0 times our E, which is 5. So now let's write this very well, dq over dt plus, so we have 5 q all over 100, 5 minus 5 is 0, so we just have 100 here. Is equal to 0. So our dq over dt plus 5 divided by 100 will be 0.05 q equal to 0. We can send this one here. So our dq over dt is equal to negative 0.05 q. So we can easily separate this. So this will be separable differential equation. So we multiply both sides by dt. You can get dq is equal to negative 0.05 q dt. So you can divide both sides by q. So we have 1 over q dq will be equal to negative 0.05 dt. How do? We integrate. So the integral of 1 over q dq will be equal to negative 0.05 integral dt. When we integrate this, it will be ln q equal to negative 0.05 t. Integrate this, it will be t plus our constant. So remember, this is a ln with a natural log e, a log with a natural base e. So to q will just be equal to e exponent negative 0.05 t plus c. We can rewrite this as q equal to e exponent negative 0.05 t times e exponent c, where using indices actually. So we'll let e exponent c to be equal to capital C. Then our quantity will be equal to, in place of this, it will be c. So it will be c e exponent negative 0.05 t. So since the tank initially holds a brine solution of salt of 20 pounds, 20 pounds of salt solution at time t, we substitute when q is equal to 20 at t equal to 0. Then we find our constant. We find the constant c. So our initial quantity of salt at time t, which is A in the equation, is this. So we substitute q equal to 20 And when t is equal to 0, then we find our constant. So 20 will be equal to CE exponent negative 0.05 times 0. So 20 is equal to CE, this will be 0. E exponent 0 is 1, so C is equal to 20. Then the first aspect of our question, we just substitute 20 to get that expression. So our Q at any point in time will be equal to 20 E exponent negative 0.05 T. So the second aspect of the equation says that we should find the amount of salt in a tank at time equal to 1 minute. So we substitute when T is equal to 1 minute, then we find Q. So we are B when T is equal to 1. So our Q will be equal to 20. That's our Q of 1 will be equal to 20 E exponent negative 0.05 times 1. In place of T, I'll put 1. So Q will be equal to 20 E exponent negative 0.05. So Q will be equal to 20 times E exponent negative 0.05 is 0.9512. Using your calculator. 20 times that will get 19.02, correct to 2 decimal place. So we can say that the quantity of salt, so they say the quantity of salt after 1 minute is approximately 19 pounds. I hope you get that. It's approximately 19 pounds. So this is it. Please play over the video and solve more questions, and I know that you understand the concept. Please remember to subscribe to the YouTube channel and click on the notification bell so that anytime I post more of this, you'll be the first to receive it. Bye-bye.